Let's look at the Acorn Area itself. The Acorn Area is a patented low-field 13 megahertz NMR device. It's small, it's portable, it only weighs approximately 7 kilos, about 14 pounds, thereabouts there, so it can be moved relatively easily itself. It comes with proprietary Area Quant software that allows you to measure relaxation and also to determine and measure the actual wetted surface area of suspensions. You can make measurements in batch mode. There's a time mode itself that allows you to do, as I said earlier, to make measurements as a function of time. And we have two temperature control options. One that allows you to move from approximately 10 degrees Celsius to about 40 degrees Celsius, and then a very high temperature option that allows you to go from ambient up to something in excess of 60 degrees Celsius itself. There's an option called the Acorn Flow, which is in fact a flow-through version of the Acorn Area. This is very useful where you want to have continuous sampling, or you want to study the effect of addition of reagents, and you don't want to do it in batch mode. It's very useful then for suspensions which are heterogeneous. In other words, you have to keep them mixed to ensure you've got basically a homogeneous suspension. Or if they're settling, because if they're settling, you can simply pump it through the NMR and make a measurement continuously with the settling suspension. The Acorn Area has had patents issued in the United States, the EU, China, and Japan. And one of the advantages of this small device, it is low field, and it is interesting that that these low field devices often have a better resolution in terms of relaxation than the expensive NMR devices used in analytical laboratories. And there's a paper by Claves et al. Which shows you the surface, which speaks to the determination of surface area via NMR, looking at frequency effects, and we're working at 13 megahertz compared with the typical analytical devices, which can be anything from 100 to 400 megahertz or more. So thank you very much for joining us on this introductory webinar, and if you go to the website, you'll find that there are follow-up webinars on all the various aspects that I have talked about today.